अगर इंसेक्ट v स्पीड से टकराया तो रॉड ने एक एंगुलर वेलोसिटी ओमेगा एक्वायर कर ली। तो बेसिकली ओमेगा निकालने को कहा जा रहा है। अगर आप गहराई से देखें तो कि रॉड किस इनिशियल वेलोसिटी ओमेगा से रोटेट करना शुरू करे जिससे जब तक रॉड यहाँ पहुंचे वर्टिकल हो उस समय तक इंसेक्ट यहाँ से यहाँ पहुंच जाए। और हमें ध्यान ये देना है हेलो स्टूडेंट्स, this is a problem taken from 1992 IIT JEE क्वेश्चन पेपर ऑफ फिजिक्स। आप में से किसी एक बच्चे ने कहा कि ये प्रॉब्लम बड़ी इंटरेस्टिंग है और उसको डिस्कस किया जाना चाहिए। I also thought it to be appropriate to discuss this question. So let us go through this question. A homogeneous rod AB of length L and mass M is pivoted at center O in such a way that it can rotate freely in vertical plane. This is a rod and it is pivoted at center point O, and the whole rod about its center can rotate in vertical plane like this. It can rotate freely in vertical plane. It means there is no friction like force here on the axle. There is no force which actually restricts the motion of the rod. It can rotate freely. The rod is initially in horizontal position. An insect S, this is an insect S of same mass as that of rod falls vertically with speed v at point C. The insect falls from here and it lands onto the rod. Just before hitting the rod, the velocity of the insect is v downward. Point C is at a distance of L by 4 from O. So this length is L by 4, this is also L by 4. Immediately after falling, the insect moves towards end B so that the rod rotates with constant angular velocity. Great. The question says that after the insect falls on the rod, it immediately starts moving towards end B with respect to the rod, and it moves in a fashion such that the rod is able to maintain its constant angular velocity. After the insect hits the rod, obviously the rod will acquire an angular velocity, and the rod continues to move with same angular velocity as the insect moves from point C towards point B. Find omega in terms of V and L. So the first question is very simple, straightforward. The first question says कि जैसे ही insect इस पे गिरेगा, how much angular velocity the rod will acquire. That is the first question. And the second question is the most interesting part. If the insect reaches end B at the time when the rod has turned by 90 degree, determine the value of V. Insect किस स्पीड से रॉड से टकराया था, that means अगर इंसेक्ट v स्पीड से टकराया तो रॉड ने एक एंगुलर वेलोसिटी ओमेगा एक्वायर कर ली। तो बेसिकली ओमेगा निकालने को कहा जा रहा है। अगर आप गहराई से देखें तो कि रॉड किस इनिशियल वेलोसिटी ओमेगा से रोटेट करना शुरू करे जिससे जब तक रॉड यहाँ पहुंचे वर्टिकल हो उस समय तक इंसेक्ट यहाँ से यहाँ पहुंच जाए। और हमें ध्यान ये देना है कि द रॉड इज रोटेटिंग विथ कांस्टेंट एंगुलर वेलोसिटी ओमेगा ऑलवेज। सो what's great deal about this question? First, let us do the first part, which is very simple, but let us do it. What are we going to do? We are going to apply angular momentum conservation about point O. As the insect falls, insect has mass m and its momentum is mv along this line. So its angular momentum about point O is simply mv into this distance, mv L by 4, isn't it? So even after collision, even after the insect lands on the rod, immediately after the insect lands on the rod, the whole system means rod plus insect, will have same angular momentum because no external torque has acted on this system about point O during that short interval of time in which insect and rod interact. जब insect इस पे just गिरने के पहले का situation और just गिरा, तो ये जो बहुत छोटा सा टाइम है गिरने के पहले और गिरने के बाद, उस ड्यूरेशन में हम बाहर से किसी फोर्स का कोई अप्रिशिएबल टॉर्क नहीं देखते। इसका वेट है, बट वो छोटा सा जो टाइम है कोलिजन के ठीक पहले और कोलिजन के ठीक बाद, उस ड्यूरेशन में उस mg फोर्स का कोई एंगुलर इम्पल्स नहीं है। ऐसा सोच के हम कोलिजन के सारे प्रॉब्लम बनाते हैं इनफैक्ट। तो हम एंगुलर मोमेंटम कंजर्वेशन अबाउट पॉइंट O अप्लाई कर सकते हैं just before insect lands on the rod. This is the angular momentum in clockwise cells. and just after the insect lands on the rod, the insect is here and the whole assembly starts to rotate with angular speed omega. So the angular momentum is simply I into omega, isn't it? So if you do those calculations, angular momentum about O before insect hits the rod is equal to angular momentum just after the insect hits the rod. So just before the insect hits the rod, this is the angular momentum, and just after the insect hits the rod, this is the angular momentum, I omega, I. How have I written I? For this rod, moment of inertia is ml square by 12 about this axis. Pen is the axis, right? Pen is the axis about which the rod is rotating. An insect can be taken as a point mass, which is at a distance of L by 4 from the rotation axis. Therefore, the whole moment of inertia of the rod plus insect will be equal to this much. This bracket is moment of inertia. So mv L by 4 is I omega. So this gives us the value of omega in terms of v. तो एक्चुअली क्वेश्चन में का जो दूसरा पार्ट कहता है कि रॉड कांस्टेंट एंगुलर वेलोसिटी से चला, जिससे कि ऐसी एंगुलर वेलोसिटी जिससे कि जब तक इंसेक्ट सी से बी पे पहुंच पाता है उतनी देर में रॉड 90 डिग्री के एंगल से घूम जाती है। तो वी की वैल्यू बताओ। एक्चुअली हमें ओमेगा निकालना है, ओमेगा निकल आया तो इस रिलेशनशिप से वी निकल आएगा। सो लेट अस मूव ऑन टू द सेकंड पार्ट ऑफ द क्वेश्चन। व्हाई एक्चुअली द क्वेश्चन इज डिफिकल्ट? What is the difficulty involved here? Let us first try to understand that. It really looks amazing that if this insect is having a weight force acting on it, how can omega remain constant? If this mg is acting here, of course the rod also has a weight force, but that weight force passes through this point. So weight of the rod does not cause any acceleration, any angular acceleration about point O. रॉड के वेट का कोई टॉर्क नहीं है पॉइंट ओ के अबाउट, वहीं से पास हो रहा है वो वेट फोर्स। लेकिन इंसेक्ट का तो एक वेट है जो पॉइंट ओ से पास नहीं हो रहा है, और इस mg फोर्स का साफ साफ एक टॉर्क दिखता है। तो जब सिस्टम पर एक एक्सटर्नल टॉर्क है तो एंगुलर एक्सेलरेशन हो, फोर्स है तो एक्सेलरेशन होगा, टॉर्क है तो एंगुलर एक्सेलरेशन होगा। तो जब एंगुलर एक्सेलरेशन होगा तो फिर क्वेश्चन बनाने वाले ने ऐसा क्यों लिख दिया कि रॉड की एंगुलर स्पीड कांस्टेंट है? कैसे हो सकता है भला? ही गड़बड़ कहाँ पे है? आपको बच्चों, आपको ये समझ आना चाहिए। मुझे लगता है आप में से बहुतों को ये बात बिल्कुल क्लैरिटी से पता होगी। जस्ट ए मिनट। जैसे न्यूटन सेकंड लॉ ऑफ मोशन है, तो न्यूटन ने जो ओरिजिनली सेकंड लॉ ऑफ मोशन दिया है, इट इज नॉट एफ इज इक्वल टू एम ए, इट इज dp by dt इज इक्वल टू एफ, राइट? Force acting on a body is equal to rate of change of its linear momentum. Now, this linear momentum is mass times velocity of the body. So, this is force. Now, only when mass of the body remains constant, mass of the system that you are considering is constant. When m is constant, you can take it outside the differential sign and dv by dt becomes acceleration. So, this equation is equal to same as f is equal to ma. This equation is same as f is equal to ma only when mass is constant. When mass is variable, I cannot simply write external force is equal to mass times acceleration. I hope all of you understand that. In a very similar way, this equation, rate of change of angular momentum, मैं angular momentum को a लिख रहा हूँ, हाँ, क्योंकि यहाँ पे L is length of the rod, so I will write it as a. So rate of change of angular momentum of the body is equal to net external torque acting on the body. Or this is true for a single body, it is true for a system comprising of multiple objects. Okay, so rate of change of angular momentum is equal to external torque. This is the fundamental equation. Now, if in this particular case a body is rotating about fixed axis, in that case this angular momentum term is nothing but I into omega, moment of inertia into omega. So if I substitute I omega here, it becomes differentiation of I omega with respect to time is external torque. Now, if moment of inertia remains constant, if moment of inertia I remains constant, then I can take it out of the differential sign and d omega by dt becomes alpha. So, I alpha is equal to torque. This equation is true only when moment of inertia is constant. So, external torque is equal to I into alpha. This is true only if moment of inertia of the system remains constant. But in this particular case, as the insect moves away from point O towards end B, this particular mass is getting at larger and larger distance from this axis. So, the moment of inertia is increasing. Can you see that? So, the moment of inertia of the system is not constant here. So, if moment of inertia of the system is not constant here, I cannot use this equation in this fashion actually. So, what I have to use is this equation rather than this equation. So, this is the major thing that you need to understand, that you cannot apply this equation for the system comprising of rod and insect. If I take rod and insect to be my system, then I cannot apply this equation. Rod plus system is rod plus insect is my system. In that case, this equation cannot be used in this manner. We have to use that particular equation. Now, there is one another thing that is quite intriguing. What is that thing actually? What actually is happening is a bit difficult to understand. Suppose somebody says that I observe the motion of the insect sitting in the reference frame, rotating reference frame, which is rotating with an angular speed omega. Rod is rotating with angular speed omega. Suppose there is an observer who is located in a reference frame that is also rotating with angular speed omega. Then, apart from the real forces acting on the insect, there is centrifugal force acting on the insect, right? Very good. But I don't know whether all of you have heard about it or not, but there is another pseudo force acting on the insect in this reference frame, that is Coriolis force. बच्चों, जब आप रोटेटिंग रेफरेंस फ्रेम में होते हो और आप जिस ऑब्जेक्ट को देख रहे हो उसमें मोशन नहीं है, अगर ये इंसेक्ट यहाँ पे रुक जाए, ना चले, मूव ना करे, एकदम फिक्स हो जाए, फिर आप इस रोटेटिंग रेफरेंस फ्रेम में अगर इंसेक्ट को देखोगे तो एक ही स्यूडो फोर्स होता है, दैट इज सेंट्रीफ्यूगल फोर्स. लेकिन अगर ये इंसेक्ट मूव कर रहा है तो इंसेक्ट के ऊपर फिर एक और स्यूडो फोर्स होता है. अगर इस रोटेटिंग रेफरेंस फ्रेम में बैठे आदमी को इंसेक्ट चलता हुआ दिख रहा है, then there is another pseudo force which is known as Coriolis force. In fact, अगर ये रोटेटिंग रेफरेंस फ्रेम खुद एक्सेलरेटेड हो तो फिर एक और स्यूडो फोर्स की जरूरत पड़ती है, जिसको कुछ लोग यूलर्स फोर्स, एज्यूमिथल फोर्स कुछ कहते हैं. बट द कोरियोलिस फोर्स एंड द एज्यूमिथल फोर्स आर नॉट इन आवर कोर्स. तो हम वहाँ भी फंस गए. और इन एनी केस अगर आप कोरियोलिस फोर्स के बारे में जानते भी हो तो दिस इज मेकिंग द सिचुएशन क्वाइट कॉम्प्लिकेटेड कि इंसेक्ट के ऊपर एक फ्रिक्शन जैसा फोर्स भी हो सकता है, शायद एक mg भी है, एक सेंट्रीफ्यूगल फोर्स भी है, एक कोरियोलिस फोर्स भी है, ब्ला ब्ला ब्ला. सो इट इज गेटिंग वेरी डिफिकल्ट. सो it will not be wise to consider, it will not be very wise to consider insect and rod separately as two objects, and it will be much beneficial to apply this equation, that rate of change of angular momentum of the whole system is equal to net external torque acting on the system without separating the insect and the rod. So, we can give this a try, and this is the right way of solving this question actually. If you have understood this, then you will be able to do it. So, now the solution goes like this. This is a rod. Let us say the insect is at a distance x from point 2, this distance is x. So, at this particular instant, the torque of mg force is, line of action of mg is this line and this distance is x cos theta. So, the torque is mg into x cos theta, and this will be equal to rate of change of angular momentum of the system about this axis. System means rod plus insect. This is the total external torque acting on the system about point 2 right now, mg into x cos theta. So, we can go by this. Torque is mg into x cos theta, and the angular momentum of the system about O at this moment is obviously I into omega, ml square by 12 for rod and mx square for insect. This insect is at a distance x from point O, so its moment of inertia is mx square. So, this is the total moment of inertia into omega. Now, we are going to apply torque is equal to dA by dt. So torque is mg x cos theta. Now you differentiate this. If you differentiate this, this quantity is nothing but a constant. Omega is a constant. Mind you, omega is a constant. So omega into this is a constant, differentiation becomes 0. We just need to differentiate this term and it becomes m omega 2x dx by dt, right? So now little bit of mathematical manipulation is required. This x cancels out, m also cancels out, actually x and m cancel out, and this dx by dt can be written as dx by d theta by dt using chain rule of differentiation, where theta is the angle by which the rod has rotated. So dx by dt has been written as dx by d theta and d theta by dt, and you just rearrange the terms, you get this. So now d theta by dt is nothing but omega, right? This is theta. Rod was initially in this position, now it is in this position, this is theta, insect is at a distance x, here is the insect. So d theta by dt is nothing but angular speed of the rod, which is a constant given in the question. So d theta by dt can be written as omega. So if I write it as omega, then the equation takes this form, right? So simplify it further, separate the variables. In fact, dx को एक तरफ कर लीजिए, theta वाले सारे term एक तरफ कर दीजिए, and you just do the integration. As per the question, when the value of x changes from L by 4 to L by 2, insect is originally at a distance of L by 4 from the center point O, and finally it is at a distance of L by 2 from center point O. So x changes from L by 4 to L by 2, and in the same time interval, theta changes from 0 to 90 degree as the rod rotates through 90 degree, rod becomes vertical, right? So just by doing this integration, you will get omega is equal to under root 2g by L. So this is the value of omega, right value of omega for the situation as described in the question to happen the way it has been described. So omega is equal to under root 2g by L, and of course as I said earlier, omega और v में relation हम already पता कर चुके हैं, 12v by 7L is omega. So in place of omega, if you substitute under root 2g by L, you get the value of v. So this is the question. So important thing to be understood here is dp by dt is not always equal to, not same as dp by dt is equal to f, is not always same as f is equal to ma. If the mass is variable, I cannot write f is equal to ma, where f stands for net external force. Similarly, rate of change of angular momentum is equal to torque. This equation should be applied only when you see that moment of inertia is not changing. I mean, I am so sorry, this equation is true always, but this equation is same as torque is equal to I alpha only when moment of inertia of the system is not changing. So I hope I have been able to clear your concepts. Thank you and goodbye.